Okay, now let's talk about logarithmic graphs versus exponential graphs. So logarithms and exponentials are inverses of each other. Now we've recently studied inverse functions previously in chapter 6, and we talked about how the in an inverse relationship, in an inverse function, the x's and the y's are swapping places. So we want to start out by remembering what exponential graphs look like and how we were putting those together. So in an exponential graph, remember those were like y equals base to the x power. They had those three special points, -1 and then 1 over base, 0, 1, and then 1 base. They had a horizontal asymptote at y equals 0. So we had y equals 0 was a horizontal asymptote here that went along there. We had -1, 1 over base. So we'll just kind of estimate that. 0, 1, and then 1, whatever the base was. Then if we did 2, it would be the base squared, so 2 base squared, and they just get bigger and bigger and bigger. So remember that one end of our exponential graph was going to ride along the asymptote, so along the asymptote here. The other end is going to zoom away from the asymptote. So our exponential graphs looked like that. They were kind of zoomy. One end along the asymptote, the other end away from the asymptote. Then the domain for every exponential graph was -infinity to infinity, because there's no value of x that would make this relationship undefined. Then the range was related to the asymptote. The range in this case started from 0 and went to infinity, but doesn't include 0. So the range was 0 to infinity, like that. So let's get our logarithmic graph going on here. The logarithmic graphs, we're going to switch the x and the y because they're inverse functions. So if I switch the x and the y, instead of -1, 1 over base, my three special points will start with 1 over base, -1, and then 1, 0, and then base 1. So those will be my three special points. Instead of a horizontal asymptote at y equals 0, I'm going to switch the x's and the y. So I'm going to have an asymptote at x equals 0. And since it's an x equal, that makes it a vertical asymptote. So I have my vertical asymptote at x equals 0. I have my ordered pair 1 over base, -1, and then 1, 0, and then base 1. Still, one end of my graph is going to go along the asymptote, in this case the vertical asymptote, and the other end is going to zoom away from the asymptote. So I'm going to go through my 3 points. One end is going to zoom along the asymptote, the other end is going to zoom away from the asymptote. So here's what a logarithmic graph looks like. It's got that vertical asymptote that it can never touch or cross. Now, since the x's and the y's switch places, the domain and the range also switch places. So instead of my domain being -infinity to infinity, it's going to switch places with the range, and the domain for logarithmic graphs will be 0 to infinity, not including 0, which you can see from the graph. If we go left to right, the x values don't start kicking in until after we're past 0, and then they keep going. And then the range for a logarithm will switch places with the domain for an exponential. So the range will be -infinity to infinity. So let's look at an example that has a numerical base. So whenever we're going to graph a logarithmic function, we always want to identify what is the base. So because that's what's going to help us make decisions about how to graph it. So in this case, the base is 2. So I'm going to list my 3 special points. They will be 1 over base, so that got real dark, 1 over base, -1. So 1/2, -1, and then 1, 0, and then base 1. So 2, 1. The vertical asymptote will be at x equals 0. And then we'll look at the domain and range here in a moment. So let's graph. Vertical asymptote, x equals 0. That's a little hard to see. Just make sure you're getting it drawn as a vertical line and not horizontal, because that would be the exponential. And then we've got order pairs at (1/2, -1), so down here, and then 1, 0, and then 2, 1. When I draw that graph, I want one end to go along that asymptote, the other end away from it, and go through all three of these ordered pairs. So we're going to curve along that asymptote and then away from the asymptote. If I look at domain, the x values don't pick up until after 0, but they won't include 0. So the domain will be 0 to infinity, and the range is going to be all the way from -infinity to infinity. Now, clearly, we're going to want to do some more graphs beyond just that, the basic logarithmic graphs. So we want to look also at transformations. So starting with transformations, this becomes very important to graphing logarithmic functions. And of course, as you know, in my math lab, they are just going to have like whatever tool it is that says, hey, what's the base? What are your transformations? And then it's going to draw them for you. But also, as you know, when you do a test, you are not going to have that tool. And so we need to be practicing our graphing on paper using those 3 special points and transformations so that we are ready for the real life graphing, and just use the My Math Lab tool as a check to make sure that you're getting them graphed correctly on paper. Okay, graphing logarithms. One of the first things that you're going to want to do is identify the base, and that's this little number that's down here in the like subscript of the word log. So that guy is our base, and it gives us our 3 starting points. So 1 over base, or 1 over a, -1, and then 1, 0, and then a or base 1. So that's where we're going to start from, and then we're going to use transformations after that to get the rest of our graph going. So let's look at what those transformations, like where they're at in the equation and how we handle them with those 3 special points. You may have a number multiplied out in front of that log. If there is a number multiplied in front, then that could be a vertical compression or a vertical stretch. So that guy is going to be a vertical compression or stretch. And what kind it is going to depend on whether that value is bigger than 1 or between 0 and 1. So if that number is between 0 and 1, then you have a compression. If that number is bigger than 1, then you have a stretch. But it could also be a reflection over the x-axis if that number is negative. So no matter what, whatever that number is out in front, what we're going to do with it is we are going to multiply the y values by that number. So in our 3 special points, we would multiply the y values by that number that's out front. All right, next transformation. If we have a number added or subtracted inside, oh, I guess I want to switch that to a different color. added or subtracted inside with the x inside the logarithm. So added or subtracted inside with that x. Then that is going to be a shift left or right. So that is a shift left or right. It's a shift left if that number is bigger than 0 or if that number is positive. It's a shift right if that number is smaller than 0 or negative. So it shifts right if it's a negative number, shifts left if it's a positive number. And so what we're going to do with that on our 3 special points is if it's shifting left, you're going to subtract from the x's. So you're going to subtract that number from the x's. If we're shifting right, then we're going to add that number to the x's. So it's left if it's positive, it's right if it's negative. All right, if we have a number added or subtracted that's not inside the logarithm. So it's either after the parentheses or it might be like in front. So it might say like 7 plus or minus log base a of something, but it's not going to be multiplied. It's added or subtracted. That is going to be a shift up or down. So this guy is a shift up or down. So it's a shift up if it's positive. It's a shift down if it's negative. So if it's shifting up, you're going to add the number to the y coordinates. If it's shifting down, you're going to subtract the number from the y's. Then we could have a number inside here multiplying by the x that's inside the logarithm. So a number times the letter x inside the logarithm. That is a horizontal stretch or compression. So horizontal stretch or compression. So it's a horizontal stretch if that number is between 0 and 1. It's a horizontal compression if that number is bigger than 1. But also remember that it can be a reflection. So it is a reflect over the y-axis this time if that number is negative. But either way, whether it's a stretch, compression, or reflection, what we're going to do is we are going to multiply all of the x values by 1 over that number. Another way to say that is to divide all of the x values by that number, but I prefer saying multiply the x values by 1 over that number. That's just my personal preference. The next thing we're going to want to do is look at the domain for logarithms. So I think I am going to pick that up in the next video.